Hello, I'm going to be making a video on the constant multiple rule. And the constant multiple rule is another basic derivative property. Um, and I'll just go ahead and show you. Let's say that a constant, which is k, so we're denoting constant by k, that's what k means, and we're multiplying that by some derivative, d over dx of f of x, right? Now the constant multiple rule says that this is going to be equal to, make that better, this will be equal to that constant times f prime of x, or the derivative of f of x, right? So it's it's essentially the same thing I wrote up here, I guess, but when you actually input values, you'll see what I mean. So if I say I want to prove this, right, you'll start off by just writing the limit, like we always do, of the difference quotient. And let's say we have k times f of x plus delta x, right? And then minus k times f of x. Okay, so I haven't done anything crazy yet, and then all of this over delta x. Okay, so really I just wrote the difference quotient using k involved here. So now what I want to do is really, it's really just one more step, one or two steps here. You'll see k on the top here, and all we're going to do is we're going to factor k out. So I can say, and I'll do the full thing here, just so you don't miss anything. So we're going to rewrite the limit as we're approaching 0 of, and what I'm going to do is I'm going to factor this k out, right? You see a k here and a k here. So I'm going to take both of these out and sit it outside of this, uh, I'm just going to sit outside of the difference quotient, I guess, right? So I'm going to put k right here, and then I'm just going to rewrite the difference quotient, right? Out of this, I factored it out of the fraction. That's what I'm looking for. All right, so then I'm just going to have what I normally have, f of, hopefully you should see this come together, f of x, I can't write, f of x plus delta x minus f of x over delta x. And then the next step should be pretty obvious. Since k is a constant and it is unaffected by any limit here, k can be factored out of the limit. And then we have k times the limit. These steps are kind of unnecessary. You can kind of just skip to the end if you see it, but I want to be rigorous here. So I'm going to go through all of it, and then we're just going to rewrite our difference quotient here. F of x plus delta x minus f of x over delta x. Okay. So what we have here is k, some constant, times the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. And that is just the derivative of f of x. So I'm going to write down here d over dx of f of x. There you go. So that's what we had over here. And I'm going to use this in an example here, right? So I'm going to say, let's say our constant here is 5. So let's say k equals 5, okay? And let's say f of x equals 3x squared, right? Now, I'm going to write this up here. I'm going to say 5 times 3, or well, 5 times d over dx of 3x squared, right? And this is just going to be, the derivative of 3x squared is 6x, so we have 5 times 6x, which is 30x. right? So it's not really complicated rule. And this is another one you'll be using a lot in pairs with the limit, or not the limit, with the sum rule property of derivatives. So just keep that in mind. And actually, if you're looking here, you could notice if you're familiar with the power rule already, you'll understand this. If not, that's fine. You don't have to worry about it. But you could notice here we already have a constant right here. So we could say 3 times x squared, or 3 times the derivative of x squared, right? That's the exact same thing. And the reason that is, it's just the constant multiple rule again, right? So we have 3, and you'll know the derivative of x squared is 2x. So we're left with 3 times 2x, and that is 6x, right? And that's the same thing we got here. So you'll notice you're going to use this a lot without knowing it. In fact, we used this earlier in the sum rule property video. So literally anytime you have some coefficient of these, you're using that constant multiple rule property without knowing it. So just kind of have that in the back of your head. Again, don't memorize it, just understand it intuitively, understand what you're doing, and it should hopefully come together. If you have any questions, let me know and I'll respond to them. But that'll do it for the constant multiple rule derivatives.